All right, my third grade mathematicians, we have been looking at two rectangles with the same area and talking about the perimeter of those shapes. We found out that rectangles that have the same area don't necessarily have the same perimeter. Now we're going to look at the opposite situation. Do you think that if two shapes have the same perimeter, the same distance around the outside of the shapes, that they will have the same area? So let's take a look at, this is actually on page 245, and it's 1 and 2. Okay. So let's first start with finding the perimeter, and then we'll check with our area. I know the purpose of the work was finding the area, but for our discussion, let's find the perimeter for both of these rectangles. Okay. So this first rectangle, remember the perimeter is the distance all the way around, okay? And so we know that one side of the square tile is 1 inch. So the measurement for this side of the rectangle is 1, 2, 3 inches. Okay. And that means, we know properties of rectangles, that means that this side is 3 inches. And I know that it tells us that each rectangle has the same perimeter up there, and it tells us what it is, but I think we also need to practice finding it ourselves as well. All right, so then up here, this side, 1, 2, 3, that's 3 inches. Draw a line here, 3 inches. And this side is 3 inches. All right, so to find the perimeter of that shape, find the perimeter of number 1, we add all the sides. Okay, so the perimeter, 3 plus 3 plus 3 plus 3 equals, our perimeter, 6 plus 6, that equals 12 inches. So for our first figure, we have a perimeter of 12 inches. Okay? All right. So what's the area of this rectangle here? So the area is the inside, so we count the square units inside, or we can multiply 1 length times 1 width. 3 times 3, 3 groups of 3, I can see that here is 3, 6, 9 square inches. So the area is 9 square inches. So the area for number 1 is 9 square inches. Okay, and remember, area is measured in square inches because that's the inside of the shape. Okay, and there's square inches, and each side of the squares is 1 inch. Okay, so let's look at the second shape. Again, I know the directions say the perimeter is 12 inches, but I like to get in the habit of solving it also to verify or to double check, right? All right, so our measurement on this side of the rectangle is 2 inches. Ooh, let me keep it with black here. There we go. All right, so 2 inches. And again, properties of rectangles, that means this side is 2 inches, and I can see that with my square tiles. Okay, this side is 1, 2, 3, 4 square inches. And properties of rectangle, that means this side is 4 inches as well. Okay, so for number 2, shape number 2, I have the perimeter of 2 plus 4 plus 2 plus 4. Again, I like to go back to that first lesson of perimeter when the ant traveled around the piece of paper. See, I'm trying to get where you can see. All right, so 6 plus 6 is 12 inches. So we have the same perimeter, 12 inches. So we're going to see if we have the same area. Okay, so the area is the inside, and I can also find it by multiplying 1 length times 1 width, 2 times 4, and I can see that here that there are 2 groups of 4, so I can 4, 8 square inches. So now we have 2 shapes that have the same perimeter but different area. So anyone have a way to think about this, and does it make sense? I think it makes sense too, because I can see that if I were to add the perimeter all the way around, I could see the distance being very close, and in fact they are the same, but the area is different. Especially with these 2 rectangles, I can see that the first one has 1 more square unit than the second one. And I think it also helps to think of perimeter like a string that goes around. That if I had a string that was 12 inches, I could put it around this shape and the second shape, and it would be the same length. So as you continue working in this investigation, I want you to keep thinking about the difference when you measure perimeter and when you measure area. Okay? So you're going to continue looking at shapes that have the same area but different perimeters, or shapes that have the same perimeter but different areas. All right, guys, thank you for your hard work today, and keep going, and I will talk to you tomorrow about more area and perimeter activities.